Hello, welcome. In this section, we will look at a case study on the weighted nine tails problem. In the preceding chapter, we introduced a case study to study the nine tails problem, and that's unweighted version. Now we will look at the weighted version. Now, in the unweighted version, so when you flip a coin and the head, and you also flip the neighboring coins, and this is all counted as one flip. In this weighted version, we're going to count the actual number of flips and use that as a weight and for this. So for example, in this one right here, we're going to flip this H right here. So how many coins are affected? 1, 2, 3. So this is actually the weight is 3 from here and to here. So now if you flip this H, you're going to flip 5 coins. So the weight is 5. Now with this difference, we just make some modifications. So we're going to have this weighted nine-tail model, and that is the subtype of the nine-tail model from the previous chapter. So here we are going to get this shortest path, but we're going to modify it instead of this using the breadth first search, and we're going to use the shortest path tree, and from the shortest path tree we get the shortest path. So this is weighted nine-tail model, and get number of flips. When you flip this vertex, and so please remember now we have 512 vertices, and each vertex represents a state of the nine-tail problem. So you have 9 coins, and the combination of all of this is 512. All right, so now let's look at this weighted nine-tail model. It's a subtype of nine-tail model. The init method, so we're going to invoke the nine-tail model and the init method. So this is all the vertices, and this is 512 vertices. And now invoke this constructor, weighted graph for the vertices, and here is get weighted edges. So this is the, when you look at the get weighted edges, so we're going to have the number of flips here. And this, and here is get the shortest path. So this is the shortest path tree. And now this is the get number of flips from here, and that's the cost. So this is the for vertex. All right, so with all of this, and now we can write a test program and to prompt the user to enter a pattern. And so this is 9 coins, and the and head, tail, and a head, and apply the model and create the model for this. So here we create the model, weighted nine-tail model, and from the model, and we can get the shortest path. And here is for this get index for this initial node, and that is the shortest path to the root, and the root is the target. And with all the tails, and in the pattern with all the tails. So that's the eventual solution. So we're going to flip all the coins and to reach to all the tails. So tails, all the tails is already 1, 1, 1, and with 9 ones. So that's the final pattern. And that's the one we use that. And so in the model, see, look in the model, we use that to build our, so this is 511. So that's the number, and with 9 ones to build our model. So this is the model, and from the model, and you get the shortest path. And from this initial node, that's the initial node. And from the initial node, we get the index. So that's get the shortest path. That is all for this section on the case study of the weighted 9 tails problem. Thank you for watching. Goodbye.